Upon completion of this module, you will be able to identify the different suspension types, including independent suspension, fixed axle suspension, semi-independent suspension, and air suspension. An independent suspension system allows the individual wheels to move up and down separately from each other in response to the road. This system provides improved ride, steering control, and stability. Since each wheel is independently connected to the chassis, it does not transfer its movement to the other wheels. Most independent suspension systems have the same basic components but can be assembled differently. The short arm and long arm, or SLA independent suspension system, typically consists of the components listed on your screen. The rubber and metal portion of the stabilizer links connect the stabilizer bar to the control arm. The torsion bar independent suspension system typically consists of the following components: torsion bar, upper and lower control arms, stabilizer bar, stabilizer links, knuckle, strut rod, bushings, and ball joints. The McPherson strut suspension typically consists of the following components: McPherson strut, coil springs, stabilizer bar, cross member, and control arm. The modified McPherson strut suspension has a coil spring that's mounted separately from the McPherson strut. The strut replaces the upper control arm. In addition to the McPherson strut and coil spring, this suspension has a knuckle, a ball joint, a lower control arm, and bushings. The twin I-beam replaces both control arms at each wheel. A twin I-beam suspension typically consists of the components listed on the screen. The strut rod limits the fore and aft movement of the I-beam while allowing up and down movements. Note that in older I-beam suspensions, a kingpin replaces the ball joints. The purpose of the fixed axle suspension is to carry more weight. This suspension is found on light trucks or full-size cars and often has leaf or coil springs on the rear axle. A fixed axle suspension has the components listed on the screen. On a fixed axle suspension, wheel movement transfers from one wheel to the other through the axle. Select the play button to see suspension movement. When finished, select Next to continue. Semi-independent suspension systems are used so that the reaction from one side of the axle won't be fully felt on the opposite side. On this type of suspension, the axle tube can flex. The semi-independent suspension typically consists of the components listed on the screen. The lateral bar is used to reduce side-to-side movement. Semi-independent suspension systems are often used as the rear suspension on front-wheel drive vehicles. A cross-member or torsion axle is used to connect two trailing arms. Even though there's a solid connection with the cross-member and the trailing arms, the cross-member will twist with each up and down movement of the wheels. This twisting action stabilizes the ride and provides semi-independent movement. An air strut assembly suspension has a rubber diaphragm that replaces the coil spring. Additional components are used to control ride height. An air suspension can be controlled and varied. An air component can be incorporated into the McPherson strut suspension. The air strut assembly has pneumatically controllable struts and electronic height sensors. Some systems use 4 sensors, 1 near each wheel assembly, and some systems use 3 sensors, 2 near the front wheel assemblies and 1 on the rear axle assembly. It also contains an air compressor with a dryer assembly, air lines between the compressor and air strut assembly, and solenoids, one for each air strut assembly. Caution: anytime a service is performed, the air suspension must be electrically deactivated and rubber diaphragms must be deflated prior to performing service. Like an air strut assembly, an air spring assembly suspension can be varied. It also has additional components to control ride height. An air spring assembly can be used in place of any coil spring suspension type. The air spring assembly has pneumatically controllable diaphragms and electronic height sensors, two in front and one in the rear. It also contains an air compressor with a dryer assembly, air lines between the compressor and air spring assembly, and solenoids, one for each air spring assembly. Congratulations, you have successfully completed the Suspension System Operation course. In this course, you have learned to identify types of suspension systems, as well as suspension components and their purposes, including springs, shocks, and struts.